Hello everyone, welcome to the course on hybrid electric vehicles developed by Jawaharlal Nehru Technological University, Kakinada, supported by Andhra Pradesh State Council of Higher Education. I am Dr. Gudipudi Nageswara Rao, Professor, Electrical and Electronics Engineering Department at Lucky Reddy Balireddy College of Engineering, Mayilavaram. The topic is types of hybrid electric vehicles. There are four main types of electric vehicles are available in today's market, and those are battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle and fuel cell electric vehicles. Electric vehicles are also known as all electric vehicles. Instead of the gasoline, these vehicles run alone on battery power. The electricity used to drive the car is stored in a large battery pack which can be charged by plugging in it to the electrical grid. Also, drivers can charge them at home using level 1 or level 2 electrical vehicle charges or use more powerful charges. At level 3 design for commercial charging stations, the charged battery pack then provides the power to one or more electric motors to run the electric vehicle because pure these typically run on battery power without an internal combustion engine assistance. They can run much faster on a single charge than hybrid vehicles. The main components of the battery electric vehicles are electric motor, inverter, battery, and control module. The working of the battery electric vehicle is simple. The power for the electric motor is converted from the DC battery to AC. As the accelerator is pressed, a single signal is sent to the controller. The controller adjusts the vehicle speed by charging the frequency of the AC power from the inverter to the motor. The motor then connected and leads the wheels turning through the axle. If the brakes are pressed or electric vehicle deaccelerates, the motor becomes an alternator and produces the power that has sent back to the battery. Advantages of the battery electric vehicles are their simple construction, operation and convenience. They do not produce any greenhouse gas and do not create any noise and beneficial to the environment. Electric propulsion provides instant and high torques even at low speeds. These vehicles are energy efficient, converting 80% of their energy input to the moving of the vehicle. In contrast, gas-powered electrical vehicles are only about 20% energy efficient. The remaining 80% of the energy and is wasted in tailpipe emissions and heat recharging the vehicle. The electric vehicle is easy, and the best part of that, no longer needs to run the fuel station to recharge your vehicle. A regular household socket can be used to charge the electric vehicle. The features of the battery electric vehicles are no emissions, not depend on oil, cost effective, low maintenance, reduced noise, pollution and easy driving. The problems with these vehicles are recharging points, short driving range and speed, longer recharge time and high price. Tesla Model 3, Renault's Joe, e-Golf, MDZ, Tot and an Exxon and Nissan Leaf are the examples of the battery electric vehicles. Hybrid electrical vehicles, these are also known as a series and hybrid parallel. Series or hybrid parallel based on power distribution. Hybrid electric vehicle have both engine and electric motor. The engine gets energy from the fuel and the motor receives the electricity from the batteries. The transmission is rotated simultaneously by the engine and the electric motor which drives the wheels. This combines helps increase the efficiency of the engine. The power distribution allows vehicles goals to achieve the optimum power under most driving conditions. A hybrid electric vehicle cannot be plugged into the charge the battery. Instead, the battery is charged by the regenerative braking and internal combustion engines. And unlike the most electric vehicles, hybrid electric vehicles charge their batteries through regenerative braking strokes, the kinetic energy used to stop the vehicle from the charging its battery and helps the IC engine accelerate. The vehicle, one type of the electric vehicle, the micro or mild hybrid uses a battery and electric motor to run the vehicle. Although they cannot run only on electric power, the maximum fuel economy by shutting off the IC engine during the complete stop. The full hybrid has the battery power to make the vehicle move using electricity alone, but generally only for the short distance. The three types of hybrid electric vehicles: series hybrid. In this, the internal combustion engine drives the electric generator and not the wheels. The generator not only charges the battery, it also powers the motor that propels the vehicle. This setup is also known as an range extended electric vehicle, since the IC engine powers the battery and the motor but never directly drives the wheels. Parallel hybrid here, both an IC engine and an electric motor propel the wheels both in work tandem and delivers the optimum power output. The batteries in the vehicle charge when the motor works as a generator. These vehicles cannot drive the stand alone. In pure electric motor series parallel, these vehicles use both IC engine and the motor working alone or in tandem. Power distribution helps the vehicle operate within its range as much as possible, giving its high efficiency. Main components of hybrid electrical vehicle: engine, electric motor, battery pack with controller and electrical inverter, fuel tank, and power electronics. The working of hybrid electric vehicle is that the fuel tank supplies the energy to the engine like a regular vehicle and the batteries run on an electric motor. Both the engine and electric motor can turn transmission simultaneously. It is a tremendous advantage in low speed conditions like urban areas. It also reduces the fuel consumptions as the engine stays off during idling periods such as in traffic jams. This feature also reduces the gas emissions. When a high speed is needed, the hybrid electric vehicle switches to the IC engine to drive. The trains can also work together, improve their performance. Hybrid power systems are used extensively to remove the turbo lag in turbocharged cars like NSX, and IC engine can charge up the batteries. And hybrid electric vehicles can also retrieving energy using the regenerative braking. There are from hybrid vehicles are primarily IC engine driven cars that use an electric drive train to improve the mileage and performance of the enhancement. The features of the hybrid: the electric vehicles are environmentally friendly, regenerative braking system assistance from the electric motor, smaller engines and higher resale value. And the problems of these vehicles are less power, it can be expensive, poor handling, and battery replacement is costly. Renault Captur, Toyota Corolla, Toyota Paris, Skoda, BMW X5 45e, E350, Nuro are the examples of the hybrid electric vehicles. Plug-in hybrid electric vehicles. The plug-in hybrid electrical vehicles, also called series hybrids, plug-in hybrid vehicles, expand on the concept of the standard hybrid vehicle. They have both an IC engine and the battery-powered electric motor. This allows the batteries to store enough power to feed the electric motor. In turn, decreases your gas usage by 60%, can save your time and money of the gas pump plug-in hybrids can travel up to the 40 miles of the electrical power alone. Rather than the couple of the miles with a standard hybrid vehicle, these vehicles can run in at least two modes. First, in electric mode, in which the motor and battery provides all the vehicle's energy, and second, in hybrid mode, in which both electricity and petrol or diesel are employed. The main components of the plug-in hybrid vehicles: electric motor, engine, battery, power electronics, fuel tank and charger. If on the board model, the working of plug-in hybrid electrical vehicle is in these vehicles start up in all the electric modes and use electricity until their battery pack is depleted. Once the battery gets drained, the engine takes over. The vehicle operates as a conventional non-plug-in hybrid. Plug-in hybrid can be charged by plugging into an outside electric power source or by engine or by regenerative braking. When these brakes are applied, the electric motor acts as a generator using the energy to charge the battery. The electric motor supplements the engine power. As a result, smaller engines can be used, increasing the car's fuel efficiency without compromising the performance. Plug-in hybrid vehicles also have facility to utilize the regenerative braking. They have the ability to run only on electricity. Most of the time makes their carbon footprint smaller than the hybrid electric vehicles. They consume the less fuel as well, and thus reduce the associated cost. The vehicle market is now quite populated with these Volt and Toyota Paris sales shows their popularity. The features of the plug-in hybrid electric vehicles are zero emissions when driving on batteries, fuel efficient in traffic, they are smooth and quiet, reduced fuel bills and tax efficient. And the problems are they are relatively expensive, complex to maintain the battery life, concerns and the resale value uncertainty. And these are the models of the examples of the cars here. Coming to the fuel cell electric vehicles are also known as zero emission vehicles. They employ fuel cell technology to generate the electricity required to run a vehicle. The chemical energy of the fuel is converted directly into the electrical energy. Fuel cells produce electricity using a fuel cell powered by the hydrogen rather than drawing the electricity from only the battery. Hydrogen fuel cell vehicles requires compressed hydrogen, the most common element of the plant. It takes about the same time as a gas car to fill up. Hydrogen is safe. It carries less energy than gasoline, but there is a limited infrastructure open to the public to fill a vehicle up with the hydrogen.